Hey everyone, today we are going to solve the LeetCode question rotate array. Okay, so let me explain with this example 1, 2, 3, 4, 5, 6, 7 and the k equals 3. So this question is very easy, right? All we have to do is just shift all numbers 3 times in this case. So 1 will be like a 1, 2, 3 here. So 2 should be here, right? And 3, 4, 5, 6, 7. Very easy, right? And I will give you one more example. So how about k equal 9? So in that case, 1 will be 1, 2, 3, 4, 5, 6, 7, 8, 9. And so 2 should be here, 3, 4, 5, 6, 7, right? So question is, how can we calculate the rotated position? Do you have any idea? So my idea is to use remainder. So length of input array is 7, right? 1, 2, 3, 4, 5, 6, 7. So we divide k divide the length of input array. So in this case, 3% 7 equal 3, right? And how about 9? So k equal 9 divide 7 equal 2. So let's check. So if k equals 3, we will get 3, right? So in that case, so 1 will be 1, 2, 3. So here, looks good. 2 should be 1, 2, 3, and it looks good. And how about 7? So 1, 2, 3, and it looks good. And how about k equal 9? So we will get 2 as a remainder. So in that case, 1 will be 1, 2, looks good. And 5 will be like 1, 2, and here, looks good. And 6 will be like a 1, 2, here, looks good. So yeah, it works, right? So that is a basic idea to solve this question. So let's jump into the code. Okay, so let's write the code. First of all, calculate the length of input array. So n equal length of nums. And then we will get a modulo. So update k with modulo. So k percent n. And then so create another array. So let's say rotated equal initialize with 0 multiply n. And then let's iterate through one by one for I in range and n. And then rotate it. So the key should be, we can do like this, I plus k and percent n. So in this case, if k is increase 1, so we can shift automatically, right? And then equal nums I. Oops, I. And then I think we have to push back rotated numbers to nums. So just for I in range and n, and update just nums I equal rotated I. Yeah, that's it. So let me submit it. Yeah, looks good. And the time complexity of this solution should be order of n, because we iterate through all numbers one by one here. So n is the number of elements in the input array. And the space complexity is also order of n, because we create a rotated array here. So that is a length of n. Yeah, so let's see the second solution. Okay, in the second solution, again, we use a remainder. So 9% 7 equal 2. So new k is 2. And let's rotate all numbers twice. So 1 should be 1, 2. So oops, 1, 2, 3, 4, 5, 6, 7. And look at the first k number. So now k is 2. So look at the 6, 7. So this number comes from this position in original input array. And how about 1, 2, 3, 4, 5? So these numbers come from this range in the original array, right? So how can we express each position, each range? So all we have to do is just swap this position and this position and this position and this position. So we can express this position just n colon colon k. So now k is 2. So that's why in reality, so k is 2. So this is an index number, and in Python, this number is not included. So actual range should be from 0 to 1. So index 0, 1, right? So we can get 6, 7. So looks good. And how about this 6, 7? So in Python, so n, and if we add negative, so we can count from the end. So negative k and to the last. So in this case, this k is included. So k equal 2, and we can count from the end. So 7, 6, and to the last. So we can get 6, 7, right? And how about this 1, 2, 3, 4, 5? So it's easy, right? Because so we already get like a colon k. So that's why we can get like this. So n and the k colon to the last. So this k is included. So that is 2, right? So from index 2 to the last. So 0, 1, 2 to the last. Looks good. And how about 1, 2, 3, 4, 5? So this case, so we already get minus k to the last, right? 6, 7. So that's why we can express like a n and colon minus k, right? And this minus k is included, other not included. So minus k should be last 2 position right here. So this position is not included. So that's why our actual range should be 0 to 0, 1, 2, 3, 4 here. So we can get 1, 2, 3, 4, 5 in this case. So all we have to do is just swap this number and this number, and this number, and this number. That's all. Okay, so let's write the code. First of all, get the modulo. So k equal k percent length of input array nums. And if k is not equal 0, so if k is 0, we don't have to rotate all numbers, right? So in that case, so nums colon k and nums k colon equal nums minus k colon and nums colon minus k. That's it. So let me submit it. Yeah, it looks good. And the time complexity of this solution should be, I think, order of n. So that's because so slice operation. So until we create until k and from k. So total of this operation should be n, right? And where n is the number of elements in the input array. And also this slice operation creates from like a minus k to last and until k. So total should be n, right? So that should be order of 2n. That means order of n. And the space complexity is, I think, order of n. So same reason. So this slice operation creates new array, which is a length of n, right? So that's why. Okay, so let's see the third solution. Okay, so in the third solution, so again, we use a remainder. So k equal 9. So k divided 7 equal 2. So new k is 2. And after that, first of all, we reverse all numbers like 7, 6, 5, 4, 3, 2, 1. And then, so we take first k number, that is 2, right? So 7, 6. And then we reverse all numbers in the range. So we have only 7 and 6. So reverse them. So 6, 7. And then after that, I think you can guess. So we reverse rest of all numbers. So in this case, 1, 2, 3, 4, 5, right? So, and actually, this is the answer. So let's check. So if k equals 9, so we rotate twice, right? So in this case, 1 will be 1, 2 here, and we have 1 here. And we have 2 here, 1, 2, and we have 2 here, right? And 3, 4, 5. And we have 6 here, and 1, 2, and 6 here, and 7, 1, 2. So looks good. Yeah, so that is a basic idea to solve this question. So let's jump into the code. Okay, so let's write the code. First of all, get a remainder. So in the previous two solution, I did like this: k equal k divide length of input array. But actually, in Python, we can do like this. And then, first of all, so let's say reverse. And first of all, we reverse all numbers. So from 0 to last index, length of nums minus 1. And then after that, so reverse. And first k number, so 0 until k minus 1. And then reverse after k to last index, so nums and then minus 1. So let's create a reverse function. So def reverse, and let's say left and right. So while left is less than right, we continue. So nums left, nums right equal, so let me copy this, nums right, nums left, and then left plus equal 1, right minus equal 1, 1. Yeah, so let me submit it. Yeah, looks good. And the time complexity of this solution should be, so first reverse should be order of n, right? And the second reverse should be order of k. And the third reverse should be order of n minus k. And the total of second reverse and the third reverse should be order of n, right? So n is a number of elements in the input array. So that means this is on, and these two are on. So total should be 2n, which means on, right? And space complexity is, I think, O1. We don't use an extra data structure, just a simple variable, left, right, and k. Yeah, and this is an in-place solution. So I think our space is O1. Yeah, so that's all I have for you today. Please support me with your actions such as comment and hitting like button. I'll see you in the next question.